All right. So if you take a look at it, the title of this lesson is called Solving. Oops, let me get my microphone hooked up to me. It'll be a little bit better. All right. So this lesson is called Solving Equations Involving Absolute Value. I think we might have mentioned absolute value maybe in passing. We didn't do a whole lot with absolute value, but let me just give you a little kind of an informal definition of absolute value. All right. So here's a number line. Oops. Got to turn this thing on, I think. That, and then that. There we go. All right, there's a number line. And let's say 0 is right here on the number line. All right, put some arrows on the end so it's a line. So let's say you had a number out here 5, and you had a number out here -5. So this is basically, it's kind of a dumbed down definition. I shouldn't say dumbed down, that sounds bad, but it's a simplified definition of absolute value. So basically what it means is the absolute value is how far a number is away from 0. You hear what I just said? If you want to write that down, you can write that down because we're going to refer to that every once in a while. So it's how far a number is away from 0. So let's take a look at 5. We'll put a dot right there at 5. Or how many units, we'll say. Now, it doesn't matter what direction it's going. It doesn't matter if it's going in the positive direction or the negative direction. It's just how far, the distance. Everybody got that? It's how far it is away from 0. So what about 5? Somebody tell me, how many units away from 0 is +5? 5, right, 5 units, okay? So it's 5 units away. So the absolute value of +5 is 5, because that's what the definition of absolute value means. What about -5? This is where it gets a little bit tricky, but that's what we're trying to get figured out right now. How far, what is the distance, how far away from 0 is -5? How many units? 5, right. Not -5, because it doesn't matter which direction you're going. Everybody understand that? It's just how far, what the distance is. If I said, go up to McDonald's and that's 3 miles away, you wouldn't say, well, I'm going to go 3 miles positive or 3 miles negative or 3 miles west or east or north or south. You just say I'm going 3 miles. Everybody got that? So distance really doesn't have a number a sign associated with it. So the absolute value of a number is just how far it is away from 0. So basically, there's no absolute value that's going to equal a negative number. You with me? I think we did this before. So, and how do we show absolute value? Do you remember the symbol for absolute value? You've done this since you were middle school at least. Oops, that doesn't. It's just a vertical. I still can't make that vertical very well. Man, alive. I'm going to get it until I get it. There we go. That's a little bit better. So this is the absolute value. It's just 2 bars and a number in between. Excuse me. So that's what the absolute value means. Again, what does it mean? It means how far is 5 away from 0? How many units? How far away is it? It's 5 places. Okay, what if I did this? What if I put a -5? What's the absolute value of -5? Again, what does it mean? It means how far away from 0 is -5? How many units? It's just 5 units. You with me? So that's basically what absolute value means. And that's what we've talked about so far. That's really all we've done with absolute value. We have not solved for x inside of an absolute value or anything like that. But guess what? That's what we're going to do today. All right. So with that said, let's now this may not make a lot of sense to you when I write it down, but after we do an example or two, it should make a little bit of sense. So this is a theorem. Okay, it's kind of a rule. It's a math rule. Okay, we call it theorems. Remember in geometry, you did a lot of theorems and stuff like that. It's just basically a rule in geometry. So what if I had this? They use the letter U. That's my U right there. And that's supposed to be a vertical up and down. Okay, so that's the absolute value of U. Using this little graphics tablet thing. Can't write quite as well on this as I normally do. All right, so what does this mean? This means the absolute value of U equals A. So if I wanted to actually solve for U, find out what U is equal to, let's just think about it. What does this mean? It means the absolute value of some number is equal to A. It means it's A units away from 0. So what could U actually equal? U could be what? There's no numbers. This is just letters. It could just be U. That's right. Okay, because U, the absolute value of U is equal to A, so just U is equal to A. But what else could you put in for U? We did it with that -5 and +5 thing. So the absolute value of -5 is also 5, right? So what could U be? U could be -5, or it could be what? +5. But in this case, it's not a 5, right? It's what? It's just a U, right? So the absolute value of U equals A. That means the same thing. I'm not going to put an equal sign here because I already got an equal sign here. This arrow just means, it means the same thing, right? So this also could mean this, that U is equal to A, okay, or U is equal to -A. And you're like, oh my gosh, what's going on there? Let's do this. There we go. Let's just see how this works with an example. We all like doing examples, right? So let's do example 1. And here's what it says. It says to solve, and I don't have my book open. I just have my notes. So I don't think this actually... Yeah, this is an equality, all right? This is not an inequality. So right here, this is equals. Everybody got that part? We're going to do a couple that have inequalities. Right now, we're just going real easy. We're going equals. So this just says to solve. There's 2 parts to this. There's an A and a B. So there's x plus 4. Thank goodness. If I could write on this tablet. There we go. So that's absolute value. Those weird lines right there are absolute value. And that's equal to 13. Well, let's use this theorem and let's write it out. So we're going to write it out 2 different ways. We're going to write, so the absolute value of something is equal to this number right here. How can you write it out? Well, you can take what's inside the absolute value and set it equal to A, or whatever's out there. And then you can take whatever's inside the absolute value and set it equal to what? To -A. And that's what we're going to do. So what's our U in this case? Somebody talk to me. What's our U, Josh? What's inside the absolute value? X plus 4, right. That's what the U is, right? It's whatever's inside the absolute value. It's x plus 4. So we take x plus 4 and we set it equal. What's the first one say? We just take that U and we just set it equal to A, or whatever's out there on the right-hand side. So what is our A in this situation? Well, since nobody's answering, I'll answer. It's 13, okay? So let's solve for x. Now it's super easy. We just solve for x. So subtract 4, x equals 9. All right? So that's one of our answers. Pretty easy. But there's 2 parts to this. Remember, there's this part and there's this part right here. So let's do the second part. Again, we're going to take the U, which is x plus 4. It's whatever's inside the absolute value. And we're going to set it equal to what? -A. So we're going to take that 13 and make it -13. So when you do these absolute values, you're going to do them in 2 parts. Okay, you're going to do just the regular A, whatever's out there on the right-hand side, and then you're going to take the opposite, which is -A. So let's solve for x now. That's easy. Subtract 4 from both sides. Take a thing. And then x equals -17. That's basically our answer right there. Okay, but how do we want to write the answer? Do you want to circle both of these? Not really. In this case, I really don't want you circling both of these because it doesn't mean that, well, it means this is our answer or this is our answer. Okay, either one of these could be our answer. So this is how they're going to write it. They're going to write it in set notation. You don't have to put that x such that. You can just put a set. They usually like to put the smaller number first and the bigger number second. So which one's the smaller number out of these 2? It's -17 and then 9. So this is how you're going to see the answer in the book, okay, in those brackets. That wasn't so hard, was it? It was just like solving x plus 4 equals 13, except you do it twice, and you make that 13, one time you make it positive, and the other time you make it negative. And then you just solve for 2 answers. You're going to get 2 answers here. So just think about it. If I put a 9 in here, let's see if this works. If I put a 9 in for x, 9 plus 4 is what? 13. What's the absolute value of 13? Is 13. So does 9 work? Absolutely. Let's put a negative 17 in here. Negative 17 plus 4 is negative 13. What's the absolute value of negative 13? It's just positive 13. Do they both work? Absolutely. So that's why you need both of those as your answer. Let's do part B. Same kind of thing. It's not much different. 2x minus 3 is inside an absolute value, plus 2 equals 7. Now, there is a little bit of a trick here that I want to do. Notice, this theorem, this absolute value is just sitting there by itself. There's nothing added or subtracted from it. Would you agree? Okay, it's just an absolute value sitting there by itself. That's what we want to do here. Before we start breaking it up into two equations, we want to make sure we just have the absolute value sitting there by itself. So what's our first step, Aiden? Yes, subtract the 2 from both sides. So that's what we're going to do. Before we even worry about separating them into two different equations, I want to get the absolute value by itself. So I'm going to get rid of the 2. So this is absolute value, 2x minus 3 equals, what's that, 5? See what we did? That was the only thing different than what we did here. Okay, you just want to get the absolute value by itself. So if there was stuff being multiplied or divided or added or subtracted, get rid of all that stuff first, get the absolute value sitting there by itself, and then you could do the rest. All right, so now, what do we do here? Again, we do two things. We take this, we just set it equal. So really, this is exactly the same as this, except we just get rid of the absolute value. Okay, we could write it a second way too. The second way is you take that a and you make it negative. So you're going to take that 2x minus 3 equals, instead of equals 5 this time, like it was over here, we make it equals negative 5. And now you just have two equations, and you just solve both of these equations. That's pretty easy. Can we do a little bit of this in our head? Add a 3, you get an 8. Divide by 2, you get a 4. Right here, add a 3. Negative 5 plus 3 is negative 2. Divide by 2, and you get a negative 1. Write our answer in, it's not an ordered pair, but it's in set notation. So what goes first? Negative 1. What goes second? 4. Put it in the set notation, and that's how I'd like you to write your answer, like this. Yeah.
So would you still be able to do when you put the 5 to a negative, would you still be able to do that if there's something outside of the lines?
No, you got to, what I said earlier was you got to get the absolute value by itself. So I said that if you're multiplying or dividing by something, you have to get rid of that first before you do the 2. All right? You could put an or right there. Okay, before you do these 2 right here, you got to make sure that the absolute value is sitting there by itself. We go to that? All right. Now, if you look at the title of this lesson, it says, well, it does say equations. But now what we're going to do is we're going to do an inequality now. All right. So even though the title of the lesson said equations for equality, we did only one of those. But now we're going to do an inequality. So we're going to start off right with an example. Let's change colors. Tired of that white. So this is example 2. And it says solve the inequality. And they ask you to graph it as well. Okay, so solve the inequality and graph. All right, so you're going to have 2 parts to an answer here. So here it is. All right. What we're actually going to do is we're going to do this inequality, or we're going to do this example, and we're going to actually come up with another theorem, okay, so that you can kind of see what's going on here. So let's draw a graph. And let's see what we can do. So let's take a look at this. You want to find all the values. How should I say this? Let's go back to the very beginning. Remember the very beginning we said, what is the absolute value of something? It means how far away from 0 it is. You remember that? Okay, so we just have an x inside of here. So what if we had a 0 here? What does this mean? This means let's find the values for x that are 4 units away from 0. That's basically what it's saying. Do you hear what I just said? Let's find the value of x. Let's find what x is. That's 4 units away from 0. So we can go 2 ways, can't we? We can go to the right, we can go to the left. So what's 4 places to the right of 0? It's just 4, isn't it? Yeah. What's 4 places to the left of 0? It's -4. Agreed? Okay, so that's going to be part of our number line right here. And what we're going to do on this, because we haven't learned the theorem yet, we're trying to develop the theorem kind of in our head a little bit. All right, so we're going to do the graph first and then see how it goes. Now it says, though, it doesn't say equal to, so I can't just put a dot here and a dot here. It says all the numbers that are less than 4 units away. You hear what I said? It's less than 4 units away from 0. So what if, could I color in outside of here? No, because that would be more than 4 units away, right? Could I color in outside here? Remember how we darken in that number line? No, because that would be more than 4 units away from 0. So where do you think it's going to be colored in? In the middle, inside, in between the -4 and the 4. Okay, so what I'm going to do, and do we put a bracket or do we put a parentheses? So this tells you right there. Do we put a bracket or parentheses? Justin, tell me. Bracket or parentheses?
Put parentheses.
Why?
Because it's not minus or equal to.
It's not an or equal to, right? Okay, very good. So you put a parentheses because it's not an or equal to. So we put a parentheses here. We put a parentheses here. And what do we shade in? Everything in between. All right, so you can color yours in a little bit better than I did. But it's all the stuff in between. So let's take a look. Let's pick a number that's in between -4 and 4. Let's say -3, all right? Stick in -3 for the x. What's the absolute value of -3? It's just 3. Is 3 less than 4? Yes, it is. Let's pick a number outside of our colored in thing and see if it works, like a 5. Put in a 5. What's the absolute value of 5? It's 5. Is 5 less than 4? No, it's not. So if you pick a number out here, it's not going to work. If you pick a number out here, it's not going to work. It's only the numbers that are in between -4 and 4. All right? So that's your graph right there. And how would you write your answer? If you want to write it in like that, oh, I forget the name of it. It's that notation. What do we call that? Interval notation. Very good. Okay, what about that interval notation? How would I write it? I'd write -4, comma 4, parentheses, parentheses. Now, this is not an ordered pair, like on an x and y axis. Kind of looks like it, right? But it's not. It means something different. It just means x is a number that's between -4 and 4, and it does not include the numbers -4 and 4. So that would be your answer. This would be your graph. Again, it's 2 parts. Solve the inequality, which is right there. Graph it, which is right there. So with that said, we come up with a theorem. And let me write down what the theorem says. I'll keep it on the same page. So here's another theorem. It says the absolute value of u, we're going to use that u again, but instead of equals a, we're going to put less than a. So anytime you see something like this, how can you write this? Well, here, what's another way? I'll tell you what, just because this is the way they write it in the theorem. What's another way I could write this? I could say x is between -4 and 4, couldn't I? Wouldn't that mean the same exact thing? Yeah. Now, the reason I did that is because they write this theorem like this, okay, where x is between 2 numbers. So what we're going to do is we're going to put u is between 2 numbers. What 2 numbers? Well, -a and +a. So that is the theorem right there. So we actually came up with it, all right? We did an example. We graphed it because we kind of know what absolute value means. And we kind of looked at it and like, oh, okay. Well, if you have something like this, that should be your answer. See that? We have a 4 here, but we had a -4 and a 4 as part of our answer. We have a -a and an a as part of our answer. So this is the theorem that works. Now, it also works if you put less than or equal to. Okay? In the book, if you look in the book, they have it written twice. Okay, I don't need to write it twice. It's less than A, or if you had less than or equal to A, it would be the same exact thing, except you'd put an or equal here. Okay, I just didn't write it twice, just thought it would take too long. All right, with that said, let's do an example. So example 3. It says solve the inequality and graph. So solve and graph. All right, here it is. It's 2x plus 4 in the absolute value less than or equal to 3. All right, if we look at that theorem that we just did, what does this tell us to do? It tells us to take the thing that's in the absolute value, which is 2x plus 4, stick it in between -3 and +3. So what we're going to do is we're going to write this like this. We're going to put the 2x plus 4 in between -3 and +3. So that's the new stuff right there. What I just did, I took this and I made it look like this. That's the new stuff that we did today. All right? And it's from this theorem. It's not that hard. Now, this is less than or equal to. We're going to do another one next that's greater than. And that's a little different. Okay? It's not the same thing. This is less than. Everybody got it? So we know how to do it with equals. Now we know how to do it with less than. So it's really important that you see the difference. So this is a less than. And now look, we did this in section 1.5, right? This was like section 1.5 part 3. We did something like this. So now we can go ahead and solve for x. So I subtract a 4 from both sides. All right, so this is going to be -7 less than or equal. That cancels out. I got a 2x. This is less than or equal, and I got a -1. Divide both sides by 2. I don't have to change the inequality because I'm dividing by a positive number. Divided by 2, divided by 2. So let's see what I get. I get -7/2 less than or equal to x, which is less than or equal to -1/2. Okay? But again, they don't want you to write the answer like that necessarily. They want you to write it in that interval notation. But look at this. This is less than or equal to. So that means we're going to have -7/2 here. We're going to have -1/2 right here. And then what kind of interval are we going to put here? We're going to put a parentheses or a bracket? Bracket, because it's or equal to, right? It's less than or equal to. So this is probably how you're going to see the answer in the book. This is how I want you to write it. Okay, I want you to write your answer like this. It also says to graph it, doesn't it? So let's graph it. It's really not that hard. When you think of graphing, you're probably thinking, oh man, I remember graphing when I was in Algebra 1 and I hated it. Well, this graphing right here is going to be pretty easy. Now, the next chapter, we're going to do some graphing and you might hate it. But on this one, you shouldn't hate this graphing on this one. This should be pretty basic. So -7.5. I'm not really sure where that lies on the number line. Let's write that as a mixed number. Do you know how to write that as a mixed number? What would it be? Negative what? 3.5. Very good. Okay, and of course, -1/2, you know. All right, so if you just wanted to put a -3.5 right there, and then a -1/2 right there, that would be fine. If you want to put like increments of like 0, 1, 2, 3, and -1, -2, -3, you could do that too and stick it where it belongs, but I'm okay if you just put it right there. Now, if we were to graph this, remember there's brackets. This basically shows you how to graph it, doesn't it? It tells you to put a bracket or a parentheses, tells you where to put the numbers right here. So I'm going to put a bracket right here, and then it's everything. It's less than, so it's all the stuff that's in between. All right? And what I just said right there is going to help us out for the next thing. So just kind of darken in all the stuff in between. So that would be your graph. So here's your answer, here's your graph. You need to have both of those. On that last homework I passed back to you, it said to graph it as well. Some of you guys only got the answer, you didn't graph it, and I took points off because that's half the work. Okay, is graphing it. That's why I took points off. I didn't take a lot of points off, but I took some points off. You got to follow the instructions and do what it says. If it's a quiz or a test, you're going to get it wrong if you don't graph it. Even if you get the answer right, if you don't graph it, the problem's going to be wrong because it asks you to do two things. It asks you to write the answer or solve for it. That's the solution right there. And then it also asks you to graph it. Okay? Let's do another one very similar to this, and then we're going to do a greater than, and then we'll be finished. So, again, it says to solve and graph. Technically, it says solve the inequality and graph the solution set or something like that. I don't know. But I'm just going to say solve and graph. So, it's less than 5. Okay? This is kind of the same thing. They do something weird happens towards the end, but it's basically the same problem. So what do? It's less than, all right? So that means we're going to put it in between. So I'm going to put a less than here and a less than here. I'm going to put a negative 5 right there because remember that negative a in that theorem. So I can put a negative 5 and a positive 5. And now I solve for x. Excuse me. So let's do that. Let's do it quick. Minus 1, minus 1, minus 1. This is negative 6. This is less than. This is negative 4x. This is less than, and this is a 4. See what's going to happen here on this next step? It's going to make it a little bit different than what we did before. What's that? Josh, tell me what I'm going to have to do here.
You're going to have to get rid of that negative 4 there next to x.
And how do I get rid of it?
Divide negative 4.
Okay, so I'm dividing by a negative, so what does that mean I'm going to have to do? Switch the signs, okay? And that's the key. Do you hear me? So if I divide by a negative, I got to make sure I switch these signs. So you got to always be aware of that. So if I divide by a negative, okay, if I just divide by a positive number, I don't switch the signs, like on that last example. But on this one, divide by a negative, I got to switch the signs. All right, so what do we get here? That's positive 3/2. Now, instead of less than, put an x in the middle. Instead of less than, I'm going to put a greater than. Why? Because I divided by a negative. Right here, same thing. Divided by a negative here, that's a negative 1. So that was the thing that's a little bit different on this example than what we just finished doing. So look at this, 3/2, that's 1.5. That's bigger than negative 1. So I don't want to write it like this. I always want, when I have this x in between, I actually want the smaller number on the left and the bigger number on the right. But what am I going to have to do now if I switch these around? What am I going to have to do to this? I'm going to have to switch the inequality again, aren't I? So doesn't this and this say the same exact thing? Yeah, because look, if I read this from right to left, x is what? If I'm going right to left, less than 3/2. Isn't that what this is saying right here? X is less than 3/2. Or x is greater than negative 1. This says x is greater than negative 1. It says the same exact thing. It's just nicer to write it like this because we always want our smaller number on the left and our bigger number on the right. You with me on that? How do I write this in interval notation then? It's less than, there's no equal, so it's going to be a parentheses, and then you just put a negative 1 and a 3/2. That's our interval notation. That's half of my answer. Why is it only half of my answer? Because I have to graph it. So let's graph it. All right, so I'll put a negative 1 right here. Tell you what, I could put a 1 and a 2 right there, couldn't I? So where's 3.5? It's in the middle. It's 1.5, isn't it? It's right there. Okay? So it's parentheses, parentheses, and it's everything in between because x could be in between negative 1 and 1.5 or 3/2. So if it could be in between, I mark all that. Okay? All right, we need to move on. Tell you what, I'm going to skip example 5 just for the sake of time. So let's go to another theorem. So we had absolute values that were equal. We had absolute values that were less than. What do you think the next thing is? I hinted about this earlier. We're going to have absolute value that's what? Greater than. Okay, so here's our theorem. It said the absolute value of u, you've seen this a couple times already, instead of equals a or is less than a, it's going to be what? Greater than a. All right? What does that mean? If I see an inequality that looks like this, how do I set it up? Do I put u in between negative a and a? Nope, it's a little different. And I wish I had a few more minutes to explain why this is true, but I don't, so I'm just going to show you how to do it. I don't usually like to do that, but we're going to. So it's going to go x is less than negative a, even though this says greater right there. This part right here is u is less than negative a or u is greater than positive a. So that's a little bit different than what we've done. So when we set this up, I could have x in here, I could have like a 3x plus 2 or something like that. Okay, we take the stuff that's in the absolute value, we set it less than negative, whatever that number is, and then we set it greater than positive, whatever number that is. All right, so basically this one right here is the same as this. Agreed? We just got rid of the absolute value. The only thing different is then you switch two things. You don't just switch that to a negative, you switch the greater than to a less than. Make sense? Maybe, maybe not. Let's do it. I'm not even going to put it in a box just because of time. Let's do example 6. And it says solve and graph. Solve and graph. And here it is. 2x minus 5. That's in absolute value. Instead of equals, instead of less than, it's greater than. So whenever you see greater than, this is how you're going to set up your inequality. Okay? So what do? I tell you what, let's do this first and let's do this second. All right, I don't know why. Just, it doesn't matter. So let's just set it up exactly the same. So we do this. All right, that's the first thing we do. We write it just like it looks. We just get rid of the absolute value. And then when we write it a second time, we got to change two things now. Not just this to a negative 3, but we got to change that greater than to a what? Less than. So you're changing two things. Do you see it? You're changing the sign of the inequality and you're changing the sign of that number that's out sitting there by itself. So we make it less than and we make it negative. And now you just solve for x. Now the answer is going to look a little weirder than what it's looked before. So let's do this and we'll pretty much, and we'll be done with this once we do this. So watch, add a 5 to both sides. 2x is greater than 8. Divide by 2, x is greater than 4. So that's part of our answer right there. Let's come over here, do the same thing. Add a 5 to both sides. 2x is less than, what's that, 2? Divide by 2, x is less than what? 1. Okay? Now, the weird thing about this, let's graph this first. Before we write it in interval notation, I think that might make sense a little bit more. So let's graph it. So what's my smallest number? It's 1. What's my biggest number? It's 4. Now, let's take a look at this. Think about graphing it. I got to find all the values of x that are what? To 4. No, what's that say? It's greater than 4. So that means, where am I going to darken my line? To the right. What does this say? X is all the numbers that are what? Less than 1, so where am I going to darken that line in? To the left. It's going to look a little weird. They're not going to come together like the other one did. All right, they're actually going to split up and go the opposite directions. So, and is it going to be a bracket or a parentheses? A parentheses. Now, it's to the left, so which way is my parentheses going to go? It's going to go that way because I'm going to the left. You see that? And then I can like darken in, color in, like this. So that's part of it. What about the 4? X is greater than 4, so I'm going to put a parentheses here, and I'm going to darken in everything to the right. Doesn't color in as well as it does on your paper, but you get the idea. That's what your graph's going to look like right there. So how in the world do I write this in interval notation? What about this part right here? What if I only had that and not the stuff on the right? How would I write that in interval notation? Where does it go? Which direction? How far does it go? To negative what? Infinity. How far does this one go? To positive infinity. So how do you think I'm going to write my interval notation just with this left one right here? I'm going to write negative infinity all the way to what? To 1. And It's going to be parentheses here and parentheses there. Okay? How do I write this one? This starts at 4, and it goes all the way to the right as far as it can go to positive infinity. Goes forever. And then parentheses on both of these. And what they do, you might have learned this back in elementary school. Do you remember like the union? Remember that big U between sets and intersection and all that kind of stuff way back when you're a little kid? That's what they're doing here. So they put a big old U to mean union. It means both of these. Okay, so you could have your answer going this way, or you could have your answer going this way. That is how they want you to write the answer. They put a big old U between there. So you put these two interval notations, put a U in between, and that's how they want you to write the answer. And there's your graph. We already did the graph, all right, but that's how you write your graph in interval notation. And that's how you do it. It seems a little confusing at first, but once you get used to it, again, once you see a greater than, how are you going to write your stuff? Well, you write it just like you did without the absolute value, and then you write it again, but you change two things. You change the direction of the inequality, and you change that to a negative. Okay? When you had less than, let's see. Okay, when you had less than, what'd you do? You stuck it in the middle, put a -3 on the left, +3 on the right, and then you just solved it. All right, so really, those are basically the two things that we learned today. Okay, is that kind of stuff right there. All right, let's give you a homework assignment. I told you we'd finish this today. It's a miracle, isn't it? All right, so your homework. Actually, I'm going to split it up. I'm going to give you a homework on 1-6 today, and then after you take the quiz on Wednesday, I'm going to give you the second part of the homework assignment. Okay, so it's going to be still 2 parts, but I taught the lesson in one period. So it's section 1-6, part 1, and it's numbers. Oh, it's page. Put the page first. 138 and 7 to 33. Just the odds. 7 to 33. The odds. That is your homework. And that's it. Okay, there's more to this, but I'm going to give you more of it on Wednesday. Okay, remember, we've got a quiz next class. The next time we have class, not tomorrow because we don't have class on Tuesday, but on Wednesday we have a quiz on section 1-5. Go back, watch the lessons. If you haven't done the 1-5 in a while, make sure that you are studied up for it, ready to go. We'll do that on Wednesday. Please be here on time.